Alright, so what I want to do is I want to go down to the bottom of the page where it says practice and problem solving. All those questions, 13 through 21, apply to this picture over here. Are you with me, Kobe? 13 through 21 apply to this picture over here. It says refer to the figure. Hope, do you want to read number 13 for us?
Yes. Number 2, name the lines that are only in plain Q.
Anybody want to take a shot at that? Chelsea?
Line HL. Line.
Okay. Chelsea's right in the middle. Trying to give us an answer. Get a book, calculator. What'd you say, Chelsea?
Line HL.
Line HL. Anybody else want to take a shot?
Line N.
Yeah.
What do you think?
Line again.
It's on a line.
It's connected between 2 points.
Can I take a short?
Sure.
Which one are we on?
13.
Okay.
What did you just say?
Joe.
That would be line N. And then Q, yeah.
Anybody else?
Was that right?
Is that not right?
I didn't say it wasn't right.
Oh.
What did you say, Corey? Right. This is a very restricted question. Name the lines that are only in plain Q. So it can't be line P.
So it's just N and Q.
Here's line P right here.
So it's line HL and what?
Line N and line Q.
Alright, this gives us the opportunity to use the different ways to name a line. Line N, you can only call it line N because they don't give you 2 points to name it that way. They only give you 1. So line can be named by a lowercase letter, so it's line N. Or a line can be named by 2 of the points that are on the line. So for the other line, you could either call it line Q, or you could call it line HL, or line LH. No. It's just getting our mind back into what we were doing yesterday. All right. Number 15. Brent, read number 15.
Name the plane containing the line of MC.
Anybody want to take a shot at that?
I will say 15.
Okay.
Yes.
Go ahead, Joseph.
Line R, or plane R, I mean.
Go ahead, Joseph.
Thank you. I think it'll be plain one. Whoa.
Anybody else? It is plain R, but what else can we name?
Plane P.
You can name it, just M and T.
Say that again?
M and T?
No.
No.
Line or plane.
Plane plane BEF.
Plane BEF.
Yeah.
So
Yeah.
you can name a plane with the italicized capital letter R, or you can name it using 3 points that are in the plane. Only the 3 points can't be on a line together. 2 of them can, but the third one can't. So Harris said BEF.
Who said that?
So,
Never mind.
yeah.
I said Harris. Harris said BEF. So you could name it BEF, you can name it BFE,
Or BFF.
BCE,
But C and E,
BEC,
C and E are on the same line.
but B is not on the same line with C and E.
Oh.
A plane is 2 points and a third point not on the line.
So it could be plane BA, and then vice versa.
Could be BCE, BFE, BFE,
ECE.
Could be something.
How about ABC?
No. I only know you
No.
got it.
Yeah, we just
Yeah,
have that
it
Oh,
one.
yeah, I can.
But it's a third.
Yeah.
Yeah.
Okay. All right. Page 20.
Page what?
20.
20?
It's a big jump.
At the top of this section, it says line segments and distance. Yeah! Yeah!
I'll be right inside as you are.
Why are you so happy?
There you are.
Oh, sorry.
Page 20?
Yeah,
Page 20, 14.
he said 20 also.
You said 20.
I was just getting so excited, I just wanted to jump right to the work. Sorry, page 14.
Okay.
Now we're going to spend a few days on this section. There's a lot in here. But just like everything else, example 1. Find each measure, assume that the figures are not drawn to scale. When you flip over to page 20, find each measure, assume that the figures are not drawn to scale. The examples are going to be just like the work. There's some things that we need to understand along the way, and the exciting part of it is every time I see that word distance, I think of that distance formula.
So I call back.
Yeah. When it's good, you call it that. Okay. A line segment. A line segment is just a portion of a line. Here's a line, kind of. Once we put the 2 arrows on each end, that means it's a line. It will go off to the left to infinity. It will go off to the right to infinity. I can take a portion of this line by identifying 2 points and labeling it. The distance between A and B represents line segment AB. A segment has a definite place to start and a definite place to stop. Yesterday we talked about how you could write the name of a line, putting this symbol over the top of 2 of the points.
You said line segment AB.
You're like, how come they don't have arrows? They just have solid
How come what?
in the book. You know how you said we had to have the arrows for to show there's a line? How come the book doesn't have it?
I'm sorry, but where are we?
Oh.
Page 14.
Where I see that, I don't see the A and B. Oh, I see it.
Mine have lines.
This is my paper.
Or arrows.
So you just, that's your paper?
Yeah. Okay. So this would be read as line AB. The arrows on both ends, just like a line does.
Yeah, and then the
Okay, hang on. This would be read as line segment AB. It definitely starts at point A and it definitely ends at point B. There are no arrows on the ends of
But I
the
thought a line never ended.
A line never ends. A line segment absolutely ends. It's just a portion of the line.
Now you cut off.
Here's a third symbol. If there's an arrow on only one side,
Starts at A and never ends.
this is a ray. This would be read as ray AB. It can also go in the other direction, and you're correct. If it's written this way, it means it starts at point A and it runs through point B. Okay, line segment. That's what we're going to be working on for a while. Line segment. Just a portion. I need you to pay attention.
She doesn't even know.
I don't care. Reading verbal descriptions. You see, line segment and a line. Line segment, line. Get that, Carter? This box right here. Line segment. There's the symbolism.
Only thing you get was
A
game.
line. There's the symbolism. Verbal representations. Word problem. You read it along and it starts using the word betweenness. Here's what I need you to get in your head about betweenness. Betweenness does not mean in the middle.
Storming outside.
Betweenness does not mean in the middle. It's not exactly halfway between. If we were reading along and all of a sudden it says point P is between points S and T. Here's what it would mean. Point P is between. Between what? S and T. So somewhere there's a point S. Somewhere there's a point T. Now where do we put P?
Anywhere in between?
Anywhere in between. Point P could be right here, right next to the S. It could be right here next to the T. It could, in fact, be exactly in the middle. But the term betweenness just means it's somewhere in that range from S to T. One of the things we do in geometry is when they give us a verbal description, we draw a picture. If they don't tell us where exactly point P is, then we have to do our best. Here's S. Here's T. And I'm just going to put point P right here because it said between.
That's PT spit.
So we're gonna have to.
Okay, I wasn't finished talking. But one of the things that may happen when you do this is when you finish your calculations, you find out that this was a very small piece and this was a very big piece. And that's why they throw in this little part here. Assume that the figures are not drawn to scale.
So we're gonna have to measure what,
No, you're going to have to calculate.
which is measuring.
How do we know how long the line is?
Yeah, that's what I'm trying to say.
There will be enough information there for you to find out. For example, example 1. A says EG. There's just 2 capital letters there, so each capital letter stands for a point. When all you have is the 2 capital letters next to each other, it means the distance from the first letter to the second letter. The first point to the second point. In the verbal description, it says EG is the measure of segment EG. point F is between E and G. We don't know where, just somewhere between E and G.
So are we looking for E and G or F?
I'm still reading. Find EG means find the distance from E to G by adding the distance from E to F and the distance from F to G. Okay. What's your question?
It says find EG by adding EF and FG, but it says point F is between E and G. How would you know exactly where F is?
You know?
And how are you going to add EF and FG?
We're going to look over here's the picture and see what it says.
What are all of them going to do like that? I thought we were trying to figure out how.
So the task is, how far is it from point E to point G? But this is called, although they haven't addressed it yet, this is called the segment addition postulate. It's a rule, and we can use this when we try to prove something. The segment addition postulate going forward says you add all the pieces together and it equals the whole thing. Just like if I asked you how much money you had, you would pull all the little pieces of money out of your pocket, you would add them together, and you would say, I have however much that total is. If you want to know how long the total line segment is, add up all of its parts. So how long is it? How long is line segment EG?
Yep, 5.
It's not raining in here yet. What did you say?
5. It's 2 3/4 plus 2 3/4.
What do you think, Sean? It's 5.5. You just add up the two measures. This piece plus this piece equals the whole thing. That's going forward. Going forward. The converse means that you apply the same principle, only you go backwards. Now, how could you go backwards in something like this?
Subtract.
Well, if you knew how much the whole thing was, and you knew how much just one part is, then you would use subtraction to find the missing part. Like if you take your total of money and you pay your bill, that's subtraction, isn't it? And the part that you get back is called your change. You're looking for the change. That's what's on the next page at the top. Look at this picture right here. Here's a new piece of symbolism. That line that ends at this bar, it starts at this bar. This is geometry's way of showing us this is the measure of the whole thing. So this line segment from A to C is 13.2 meters long. From B to C is 5.8 meters long. So what's the measure of the missing piece right here?
7.4.
8.4.
7.
7.4.
7.4.
Kind of says right there.
How'd you get 7.4?
Because I take 13.2 minus 5.8.
It's the whole thing subtracted by the piece that you know. It will give you the piece you don't know.
Which is not 8.4.
All right. 1B. What does that mean? When it says QR?
Line QR.
What does that mean?
Point.
Oh, points QR, yeah.
So you want to find what?
What does it mean?
You have to find what the distance is from Q to R.
Good job.
Thank you. What is the distance from point Q to point R? All right, here's your information. Find me the distance from Q to R.
13 3/4 minus 6.
Oh, and I need a mixed number. Hmm? This one.
7
Yeah. 7 point.
No, I need a mixed number.
718.
718.
So it's calculated to 57.
Now the instruction part is going to stop here. All right. We've talked just about two things today. Really the same thing, but in two different ways. Going forward, you just simply add up all the pieces and it tells you how much the total is. Going in the opposite direction, which is called the converse, you start with the total, subtract off the parts you know, and it tells you what the part is that's missing. So your assignment will be on page 20.
Can we add on?
What?
Can we add on to what we did yesterday?
Yeah.
Show.
Just draw a line and write P20. Okay, this is going to be kind of a unique numbering system here because I'm only going to give you the ones that use numerical values. Tomorrow, we get to add in the alphabet. Okay. So 1, 2, 5, and 6. And then 11 through 16, all of these. So that's just 10 problems. 1, 2, 5, 6, and 11 through 16.